Hey guys, welcome back. Today we're going to talk about direct and inverse variation. A direct variation is a specific relationship in which there is a constant multiplier, okay, between all ordered pairs. Okay, so if I had ordered pairs x and y, and I had 0, 0, 1, 1, 2, 2, 3, 3, my x values are my inputs and my y values are my outputs, okay? This is an example of a direct variation because as my inputs are increasing, my outputs are also increasing. So that would be a direct variation. It's all because it's also going through the origin. Okay, that's important. A direct variation is written in the form y is equal to kx. So instead of using m for slope, we're using another variable k, but it really is the same thing, okay? You're thinking about it, the slope of the line is actually known as the constant of proportionality, we're going to call it. So that is the constant of proportionality. Okay, and that's another name for that multiplier that we're talking about. So that's the k. K would be equal to that, the constant of proportionality. So if we wrote the equation y equals kx and treat it like a literal equation, and we solved instead for k, we can say that k is actually equal to y divided by x. Because if you think about it, if you divide both sides here by x to get k by itself, you would end up with k is equal to y divided by x. So the graph of a direct variation always goes through the origin. Okay, that's important. Always goes through the origin. So looking right here at y is equal to 5x, that's an example of a direct variation. And the constant of proportionality is that coefficient before the input variable, which would be 5. So again, it's another name for the slope in this situation, or the rate of change. Okay, we call it the constant of proportionality. All right, so this example, y equals 5x plus 5, is not an example of a direct variation because we are not going through the origin. Okay, you have to go through the origin. So this is an example that is not, it's not an example. So there's your graph for y equals 5x. Again, notice you're going through the origin. Okay, an inverse variation is a relationship between two variables in which the product is a constant. So let me try to squeeze in an input-output here. So if I had x and y, and maybe I had 1 and 24, 2 and 12, an input of 3 and 8, 4 and 6, okay, 6 and 4. Notice what happens as your inputs here are increasing. You notice your outputs are actually decreasing. So that would be considered an inverse variation. And if you multiply your input and your output, you're always going to get that 24. 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24. And that, when you multiply them together, is the constant of variation, or the constant of proportionality in an inverse variation. So an inverse variation is written in the form of y is equal to k divided by x. Okay, where again that k is the constant of proportionality. So let's write that in again. K equals constant of proportionality. Okay. All right. Now, if this was a literal equation and we solve for k, we could say k is equal to, we would multiply both sides by x, we would get x times y. Okay. So to solve for k, first you get k is equal to x times y. And anytime you graph an inverse variation, you can do this on Desmos, you're going to create a graph called a hyperbola. Okay. So y equals 5x is an example of an inverse variation, and the constant of proportionality in this case would be the 5. Okay, now be careful, the 5 needs to be in the numerator. Okay, in the event it's in the denominator here, this is not an example of an inverse variation. It's actually an example of a direct variation, because if you think about it, x divided by 5 is the same as 1/5 x, or the coefficient there would be 1/5. So that would be a direct variation, and your constant of proportionality would be equal to 1/5. Okay, so the next few examples say to tell whether the equation represents a direct variation, inverse variation, or neither. Find the constant of proportionality. So if you look at the first one, it's in the form, remember, direct would be y is equal to k times x. Okay, so, and an inverse would be y is equal to k divided by x. All right, so the first example is in the form of a direct, and the constant of proportionality would be a -5. The second one, if you look at it, it would be in the form of an inverse. Okay, it's an inverse variation, and in this case, our k would be equal to 2. All right. Now, for this one, when we solve for y, get y is equal to x plus 4, but if you notice, we have a y-intercept that's not 0, so it doesn't go through the origin, so this one would be neither. Okay. Number 4, r is equal to 9 divided by t. You don't have to have your inputs and output variables, but, okay, assuming that r is your output and t is your input, then this would be an inverse variation, and your k would be equal to 9. Okay, 5. You can try 5, 6, 7, and 8, and then check your answers. Just pause the video. This would be a direct with your k equal to 1/2. This one would be also a direct. This, you got to be careful, because if you notice, your variable, your constant proportionality is not in the numerator, so that's actually a fraction. Your k would be equal to 1/18, because that's I over 18, which is the same as u is equal to 1/18 I. Those would be equivalent. Number 7, when you solve for y, you get y is equal to 1 divided by x, so that would make it an inverse, and your constant of proportionality would be 1. Okay, for this one, you've got z, you're in the form of an inverse, and your constant would be -2. Okay, so try 9, 10, 11, and 12, and then check your answers. Okay, this would be neither or none. Okay, this one, if you solved, okay, divide by -3, you're ending up with y is equal to x. So in this case, it's direct, and your k is equal to 1. Okay, if you solve for y, you would multiply both sides by x, so 4x would be equal to y. Okay, or y is equal to 4x, so this would be a direct, and your k would be equal to 4. All right, to solve for your y here, let's start out and multiply both sides by y. So that would be 8 is equal to 2xy. All right, just multiply both sides by y. Okay, and then we're going to divide both sides by 2x. So 8 divided by 2x would be 4 over x would be equal to y, or y is equal to 4 divided by x. So that would be an inverse, and your k would be equal to 4. Okay, all right, let's look at some tables now. So we want to know if the table represents a direct variation. If yes, write the equation. Well, anytime I see direct variation, I think y is equal to k times x. Okay, so that means then our constant is equal to y divided by x. We're just, again, a literal equation solving for k. So what does that mean? It means if you're looking at a table and you take your y value and you divide by your x and you always get the same number, then you can say the table represents a direct variation. And that constant of proportionality would be the k. Okay, so let's look at this one. So since k is equal to y divided by x, we're going to say 3 divided by 1, that's equal to 3. 6 divided by 2 is 3, 9 divided by 3 is 3, and 12 divided by 4 is 3. Okay, so this would be, yes, it is a direct, so y would be equal to, our k would be 3, right, because it's always 3, so y would be equal to 3 times x. There's our direct variation. Okay, here, if I took -1 and divided by -3, I would get 1/3. 1 divided by -1 gives me -1. Well, I don't have to go any further because I know they have to all be the same. So I'm going to say that this is no. It does not represent a direct variation. This one would be 0 over 2 is 0, 1/4. So again, I have 2 that are different, so that would be a no. Okay, 5 divided by 10 would be 1/2. okay, or 5/10. 4 divided by 8 would be 4/8, which would be 1/2. Here we have a half and 1/2. So that would be yes. And in this case, our k would be equal to 1/2. So we can write the equation, excuse me, as y is equal to 1/2 x. Or you might see it as y is equal to x divided by 2. They would be equivalent, okay? All right, so now moving on to a table representing an inverse variation. Remember, inverse y is equal to k divided by x. If we solve for k, k would actually be equal to x times y. Okay, think again like a literal equation. What does that mean? It means if we take our x and our y and we multiply them together and always get the same number, then it can represent an inverse variation, a variation. So let's take our x times our y. X times y is 22, and then we get an 84. So we don't have to go any further. We can say, no, it's not going to represent an inverse. Okay, x times y here would be 20. Okay, negative 4 times 5 would be 20. So each one of these, when you multiplied x times y, is 20. So we know that it is an inverse variation, and our k is equal to 20. When we write the equation, it would be y is equal to 20 divided by x. Okay, so now in this one, when I start multiplying, I've got 1,600, then I've got 8,464. So as soon as I do that, I know it's going to be a no. And then number 20, okay, I multiply them together. I've got 18, 18, 18, 18. So they're all the same, so I know it is going to be an inverse variation. In this case, our k is equal to 18. So I can write this as y is equal to 18 divided by x. Okay, now looking at graphs, it's pretty easy. Okay, direct variation must go through the origin. Okay, must go through the origin. All right, and it's going to be a straight line. So in this case, I know we've got y is equal to 2x. It's a little shifted, but it is going through the origin, so it is a direct, and the k would be equal to 2. All right, this one, y plus 3, we know we're not going through the origin, so it is not a direct variation. And for this one, we've got it is, and if you notice y equals negative x, so our k is the same as the slope, which is negative 1. All right, now the graphs for an inverse variation must be a hyperbola. Now hyperbola actually is going to be a curve. It never hits the x or the y axis. It just approaches it. And a hyperbola is either going to be in both the first, that's a terrible one, first and the third quadrant, or it could be in the second and the fourth quadrant. Okay, so kind of a bad shape. But looking at 24, we're going to say no. We got no. That's a no. 26, 27, yeah, there we go. We've got a kind of a funny looking hyperbola. Yes, this one's a no. Line, definitely not. Okay, circle, nope. Okay, here we have a hyperbola. It kind of shifted a little bit, but this is yes, and then this is yes. Okay. All right, so here's the part of the notes where it gets a little bit more complicated, but if you pay attention, okay, it should make a little sense. Okay, given that y varies inversely with x, okay, as soon as I see that, I think of y is equal to k divided by x. Okay, and since k divided by x, that means that if we solve for k, that's the same as our k is x times y. So we need to first figure out what our k is, and since it's an inverse relationship, k is going to be equal to x times y, which means k is equal to 7 times 2, which is our 14. Okay, we're going to take our constant and we then put it back into the equation. Okay, we're going to use the specifies value and write an inverse variation equation. So that means we got our k. As soon as we get our k, we can write our equation. There it is. Okay, that's the first part. The second part says, then find the value of y when x is 2. So we just let x be equal to 2, and our y is 14 divided by 2, which is equal to 7. So our y is 7. So each one of these questions has two parts to it. All right, so inverse variation, we know our k value is the x times the y. So our k is going to be equal to 3 times 9. which is 27. We write our equation, y is equal to 27 divided by x, and then we plug in where x is 2. So y is going to be equal to 27 halves. Okay, our k is equal to our x times y here. So now we've got our k is negative 3 times 1. So our k is negative 3. So our equation is y is equal to negative 3 divided by x. Okay, there's our inverse variation. And when we plug in 2, our y is going to be equal to negative 3 halves. Okay, for 36, since our k is equal to x times y, k is equal to negative 5 times 40. Okay, our k is negative 200. Our y is equal to negative 200 divided by x. There's our equation. And then when we plug in, again, we're using the same number. Let x be equal to 2 again. When we plug it in, we've got y is equal to negative 200 halves, which is negative 100. So y is equal to negative 100. Okay, 37. We get our k value, and at any time pause the video and rewind, okay? It's an inverse variation, so I keep going back to this literal equation to get our k. K is the x times the y. So k is going to be equal to negative 5 times negative 11, which is 55. So our equation is y is equal to 55 divided by x. And when we plug in the 2, we get y is equal to 55 halves. Okay, and then k is equal to x times y here, so our k is going to be equal to, I'll squeeze it in, negative 18 times negative 4, which is, our k is 72. So y is equal to 72 over x. There's our equation. When we plug in, let x be equal to 2, we get y is equal to 72 halves, which is 36. So y is equal to 36. Okay. Moving on now, okay, last bit of it, we have y varying directly with x, okay? So as soon as y varies directly with x, we think y is equal to k times x. That means if we solve for k, k is equal to y divided by x, okay? And that's what we're going to use here. We want to get our k first. Okay, we're doing the same thing. But now we're writing a direct variation equation, and we're relating x and y, and then we're finding the value of y when x is 3. Okay, so for our k, we've got k is equal to 8 divided by 2, which is 4. Okay, so y is going to be equal to 4 times our x. There's our direct variation equation. All right, and then we let x be 3, and we just multiply. Y is equal to 4 times 3, so our y is 12. There's our answer. Okay, and then number 40, when you do number 40, your k is going to be equal to y divided by x. So k is going to be equal to negative 3 divided by negative 3, which is 1. Okay, so your equation is going to be y is equal to x, okay, or 1x. And then when you plug in your x is equal to 3, okay, you're going to get y is equal to 3. Okay, 41, okay, when you do this, your k is going to be equal to y divided by x, which is going to be 12 divided by negative 6. So your k is negative 2. So your y is going to be equal to negative 2x. Okay, so there's your direct variation equation. When you plug in x being equal to 3, okay, you're going to end up with y is equal to negative 2 times 3, or negative 6. Okay, so if you guys want to pause the video here and try the next 3, you can. Okay, so when we do this, okay, we end up with k is equal to y divided by x. Or again, you can always go back to the direct variation equation and say y is equal to k times x, like that. Those are equivalent. You could do it like this, where I put in 16 as my y, and then I'm solving for k. So again, I'm really just dividing the 16 by 2. So I end up with your y is going to be equal, your k is going to be equal to 8 in this case. Okay, so your k is equal to 8. And then you plug it back into this equation. Y is equal to 8x, okay? There's your equation. Then you multiply the x, let the x be equal to 3. And your y is equal to 8 times 3, which is 24. Okay? All right, so let's try it this way again, too. Our y is equal to k times x, so our y is 2. Our x is 1/4, so k times 1/4. We got to multiply both sides by 4, and we end up with 8 is equal to k. All right, so our equation again is y is equal to 8x. So when our x is 3, again, our answer is going to be 24. Okay. And then the last one here, okay, I'll go back to, let's just say k is equal to y divided by x. When we do that, okay, we've got 10 divided by 3, so there's our constant. So our equation is y is equal to 10/3 x. It's okay to have a fraction. There's the first one. And then when we multiply, we let x be equal to 3, okay, x is 3, we end up with y is equal to 10/3 times 3, which is 30/3, and our y is equal to 10. Okay, that's it. All right, so if you need some help with the homework, you can go and try to make a little video for homework help too.